Hello, 6th grade. It is Miss Odell, and I'm happy to join you here on lesson 18, which is titled Chemical Weathering. And this lesson is going to be coming from pages 30 to 33. I'd like for you to open your book up to page 30 and follow along with me. All right, so today we're going to be talking about chemical weathering, but I want to back up and review with you about mechanical weathering, because there's two types of weathering that we're talking about. That's mechanical, and then today's going to be chemical. But remember, mechanical weathering is the process of breaking rocks into smaller pieces. There are several different types of mechanical weathering that we talked about yesterday, like frost wedging, frost heaving, pressure release, exfoliation, which is pulling the sheets of the rocks off for different ways, abrasion, and then other catastrophic events. But chemical weathering is a little different. All right, and the difference in chemical weathering is, if you look with me on page 30, you will see some pictures there, and that kind of gives you an idea of what chemical weathering looks like, because basically chemical weathering, it transforms the rock or the substance into a new substance. Okay, so it changes the look of that substance. Okay, so follow along with me as you see here, and I'm going to have you to highlight some things as I go along. All right, so unlike mechanical weathering, which changes only the size and the shape of the rock, that is important. Chemical weathering changes the rock into a different substance. Now, there's a most common type of chemical weathering, and that's called oxidation and reaction of acids, and that takes place with the minerals in the rocks. So most of us have seen oxidation. Perhaps you've noticed garden tools, or any type of outside tools that are metal that turn to rust. Well, when oxygen combines with the air, with the iron oxide, which is the former name of rust, forms. Okay? It is in a similar way, oxygen from the air combines with the rock is made to form new compounds that can cause the rock to weaken. Even if you see those things that have rust on them, a lot of times they have so much rust that the area is getting weak and can be brittle and break off. Okay. Another type of chemical weathering. So the first one that we talked about was oxidation and reaction acids. The next one we're going to talk about is another type of chemical weathering, and this is when rain carries chemicals from the air onto the surface below. So, Earth's atmosphere contains both water and carbon dioxide. So we know what our atmosphere does, and that contains water and carbon dioxide. So when that carbon dioxide dissolves into water, it forms a weak acid called carbonic acid. Highlight that. Carbonic acid. Okay? Now, through carbonic acid is relatively weak over long periods of time. You can see the effects of carbonic acid in an old graveyard, just like you see here, and how these gravestones have been affected from acid rain. Okay, so carbonic acid by itself is not harmful. Okay, so keep that in mind. It's not harmful by itself. However, to plants and animal life it is. However, also man has introduced an additional chemical to the atmosphere, and that happens by burning fossil fuels from oil and coal. So one of the most common compounds produced by fossil fuels is sulfur dioxide. Sulfur dioxide in smoke, when it's combined with water in the atmosphere, it also produces, this is important, sulfuric acid. And then when that comes down and that rain comes through the atmosphere and it gets the sulfur acid and the carbonic acid and any other chemicals that is stronger weather. It begins to weather down rocks and more quickly when it contains that carbonic acid. Now, looking over to the next page, we can see here I have this underlined already. It's important then. You can see the effect of trees up here that have been affected by acid rain. So the stronger acid is called acid rain. And like you have industries that produce smoke and exhaust from cars, especially when you live in a city and there's a lot more chemicals that's in the atmosphere, more likely to have the kind of chemical weathering. Now, upon upper level winds, there's a lot of winds that that affect many things as well, like we talked about in mechanical weathering yesterday, as that heavy wind picks up that debris and it brushes across the weaker rocks, and it can deteriorate that rock in a lot of ways. Now, another kind of chemical weathering, it can be seen in a forest, which is lichens and mosses. And you see those on rocks. We see those around here. And let's highlight that, lichens and moss right here, okay? Lichens and moss is another type of chemical weathering. Make sure you underline that as well. And you can see here how they grow on rocks. And because these organisms do not have true roots, they can survive on very, very little water. Even though they're plants, they don't need a lot of water. While they attach to the rocks, these organisms, they secrete an acid that dissolves the rocks, and it breaks down rocks even further. So, whether by wind, weather, acids, or living organism, God uses mechanical and chemical weathering to break down rocks. Okay? Nothing is by mistake. Everything is exactly the way God wants it. I want you to take some time to read about this fantastic fact about Jim White, how he discovered one of the greatest cave systems in the United States. And as White was writing home, well, I'm not going to read it to you because I want you to read it due to timing of the video, and it takes so long to upload them. However, I do like to take field trips sometime this time of year to caves so that we can see the stalactites and stalagmites and how they form and things like that, other than just reading in the book. So maybe sometime we can get that rolling this year, even if it's past this chapter. Okay? So, caves. Weathering forms many kinds of caves. Crashing waves, wind, and running water can all form caves. Think about that. Crashing, that's lots of water that is crashing and pushing up against rock. Waves and running water can form caves by mechanical weathering. However, in the opposite here, in chemical weathering, that forms the limestone inside the caves or caverns. Just like I said, the stalactites and the stalagmites. Okay? So as the acid water seeps into the cracks of the limestone down and up, it dissolves calcite in the limestone. Now, how many have you ever been splunking, speleothems, which talks about people that are splunkers? They like to go, and right here's that word. They like to go and explore the caves. My husband did that a few times when he was younger. Anyway, so you can actually go and see the beautiful formations in the caverns, and even in caves that aren't set up for tours, you can see even more beautiful sights. It can be dangerous, but you can. All right, so there are beautiful formations in a cave, and these form as dissolved calcite is deposited out of the water. Remember that word, calcite. It's dissolved calcite, okay? Now, some of the most common structures in caves are stalactites and stalagmites. There is a difference. Stalactites hang from the ceiling. Stalactites are the ones that hang from the ceiling, okay? And they look like icicles. Stalag with a G mites, they grow up from the ground. I always think about the G going with ground because they grow up from the ground as a result of that calcite dripping from the ceiling. It comes down to the ground, and then it accumulates up and builds the stalagmites. Now, let's go to the next page. All right, so here are some pictures of some stalactites. They hang tight from the ceiling, right? Stalagmites, they come up from the ground. That's how I always remember the two. Now, a drip curtain forms when water seeps in along a crack and hardens, leaving calcite behind in a long, delicate curtain sheet. Beautiful sight. And then there's columns form when a stalactite and a stalagmite, they grow together, just like this right here. This is how they form, up and down. They grow up and they grow down, and then they meet, and it forms a beautiful column, okay? So the three questions here that go along with our lesson is, how does chemical weathering differ from mechanical weathering? Think about that for a second, okay? And then I'm going to tell you the answer. So in chemical weathering, the chemical makeup of the rock is changed, okay? So it becomes a different looking structure. While mechanical weathering changes the size and the shape. Think about that. Mechanical weathering changes the size and the shape. Chemical weathering changes the makeup. Now, the next question, what causes acid rain? Well, that's pollution. Pollutants, as well as burning fuels and different things that are in the air. And when that combines with moisture in the atmosphere, it creates acid rain. You don't have to write these down. I just want to go over these with you, okay? But you can if you want. Acid rain seeps through the soil into cracks in limestone. It dissolves the limestone and leaves behind formations in the cave. Okay? That is how speleothems form, and that's how they dissolve acid water. It seeps through the soil and into the cracks in the limestone, and that dissolves the limestone and then leaves behind the formation of the cave. Then you have your stalagmites and stalactites. Okay, now, again, make sure you read about that fantastic cave. Today, I'm not going to give you any additional assignment other than I want you to reread this lesson and make sure that you have the important things highlighted, and post on that you completed and that you watched the video by posting the word in your assignment section where you post your assignment. Post the word chemical weathering. That tells me you watched this video, and you will get a 100% for that completion grade. All right, 6th graders, you guys have a wonderful day.